Let us try a hard problem. It is not a hard. If you understand, it is a very simple. If you do not understand, it is a very tough. Let us see. So, the question says, show that the function f of from x to y, function from x to y, where x is r, real minus 2 and this is y is r minus 1, defined by f of x is a bijective function. Now, clearly this is a rational function, and I have taught you how to draw the rational graph of rational functions. Now, you can see let us take the function. So, as usual, as I have taught you earlier, how to, we will first draw the function, we will find out its domain and range, and then everything will get clear for you, and then within 2 minutes you will be able to find out the answers. So, first of all, f of x is equals to what? F of x is x minus 1. As I have taught you, this is a rational function. As it is a rational function, and you can see the degree of both of them is same, degree of the numerator and the degree of the denominator term of the powers of the x, highest power of the x is being the same, correct. In this case, when degree are being same, then first we need to find out the horizontal asymptote and vertical asymptote. So, first of all, let us find out the horizontal, first of all let us find out the vertical asymptote. To find the vertical asymptote, it is very easy, we equate the denominator to 0, that means x minus 2 equals to 0. So, x will be equal to 2 is our vertical asymptote, very good. What about the horizontal asymptote? To find the horizontal asymptote, in this case we have to compare the coefficients. So, here the coefficient is 1, here also the coefficient is 1. So, we have to compare the coefficients of the both the of the highest power of the polynomials. So, here it is 1 and 1, correct. Hence, the horizontal asymptote will be at x equals to 1. Actually, we need to divide them. If let us say if it was 2, then it would have been 1 by 2, half. If it was 3, or it would have been let us say 2x minus 1 by x minus 2. You see, in this case of the degree being same. So, therefore, in this case our horizontal asymptote would be just 2 by 1. So, that is x will be equals to your y will be equals to your 2 only, that is it. In this case, that much. So, just we need to do that. Okay. So, now, so x equals to 1 is our is going to be our horizontal asymptote, got it. So, what next we find out the y intercept. So, or we find out the x intercept. Let us find the x intercept. Is there any x intercept or not? So, to find the x intercept, we make y equals to 0 in the above equations. If I put y equals to 0, that means f of this equals to 0. So, this is actually y. So, if I make this equals to 0, I get x minus 1 equals to 0. That means x equals to 1. The intercept is at x equals to 1. For y intercept, we make x equals to 0. So, if I make x equals to 0, I get y equals to half. Okay. With these data, let us plot the graph now. So, this is our axis. Okay. Now, first thing is what? Our vertical asymptote is at x equals to 2. So, this is 1, this is 2. So, let us make a dotted line here. So, this blue line represent our vertical asymptote. Okay. Asymptote is actually a line, horizontal or vertical line, through which the curve will follow this curve, but it will never meet, it will never intersect. It will be around this point line only, but it will never meet it will never cross this line. So, that is called the asymptotes. Now, let us see what is the horizontal asymptote now. Horizontal asymptote, it is at x equals to sorry, this would be y equals to 1, not x equals to 1, it would be y equals to 1, will be at y equals to 1. So, where is y equals to 1? That means this line. Okay. Now, x intercept. So, x intercept is at y equals to 0. So, that means y equals to 0, I get x intercept at x equals to 1 value. So, at x equals to 1, y will be 0. No, x equals to 1, y will be, so this is a 1, here the y will be 0. So, here it will be 0. Okay. And y intercept would be x equal to 0 half. So where is half? Where is half? So this is half, so that means here is the point. Then the graph will be as usual, it will be the same way only how we draw. So it would be something like this, and in this case is very easy. You can check in the graphical calculator Desmos, you will find the same thing only. Got it? So this is the curve, these are the x and y intercept. Now tell me, is it easy to check whether it's a bijective or not? The first test how to check whether it's a bijective or not, horizontal line test. So do the horizontal line test. What should I do? I should draw a straight line. I should draw a straight line. Here is the first line, and here is the another dual, and the second range, that is the negative range, also make horizontal line. You can see at every point. No, oh, before I go to the test, look at the domain. What is the domain? We need to find the domain first. What is the domain of these functions? So domain will be real, domain all the x values. So it is coming from minus infinity to plus infinity, but wait a minute, there is at x equals to 2, this asymptote value cannot be taken. So the range will be minus 2. Is this given to you? You can see this is given as x, this is the domain. So what is the range now? Range will be all the y values. Again it is real, only. So range will be, here we should not have 1, so that means range would be real minus 1, check. Here is a real minus 1, this is our range. Very good. Now let us check the bijectivity. So to check the bijectivity, first thing what you should do, we should just check the horizontal line test. You can see for every y, for every x there is a unique y within that range, right? So we can clearly write for all x element of, now we are not going to write in terms of x and all, we can directly write r minus, because we have understand it, this there exists y element of, from where, real minus 1, hence the function is 1 1, function is 1 1, but is it onto? To check the onto, check all the y values are included or not. Again you can see all the y coming from minus infinity up to, this is 1, no, and this is all, this is 1, I think this is half, yeah, this is half the intercept, no, not this point, up to this point I am talking about, sorry, this is 1, up to 1 everything is included except 1. Again from here all the values will be included, all the values of y has its corresponding x, is it or not, single x. So therefore you can see, if I draw the line, you can see here for a y there is an x here. Similarly if I do it for this point, there is, similarly for here there is, every y is actually, so we can write what we should write, we can write frame of sentence, for all y element of real, what, element of real minus 1, for all y it is a, for all y there exists an image, there exists a pre-image x element of real minus 2 under f of x, hence the function is bijective, hence the function is bijective, proved. Got it? See, if you understand, so simple, is it or not?